This is the universe as we've never seen it before. Breathtaking galaxies, shimmering nebulae, the very pillars of creation. But what if I told you that this incredible view was almost lost to us? That the very instrument that took these pictures, the Hubble Space Telescope, was launched broken? When Hubble first opened its eye to the cosmos in 1990, this is what it saw: a multi-billion-dollar blur. It was a national embarrassment, a symbol of failure that threatened to blind us to the universe just as we were poised to see it with brand new eyes. This is the story of NASA's greatest mistake, and the incredible mission to fix it in the vacuum of space, turning an epic failure into a legend of discovery that would change our understanding of everything. The promise and the fall. The Hubble Space Telescope wasn't just another satellite, it was the culmination of decades of dreaming and engineering. Named after Edwin Hubble, the astronomer who confirmed that our universe is expanding, the telescope was designed to be our sharpest eye on the sky. By orbiting 340 miles above Earth, it would escape the distorting blur of our atmosphere, the very thing that makes stars twinkle, and capture images with a clarity that ground-based observatories at the time could only dream of. It carried a 2.4-meter primary mirror, polished to near perfection, intended to gather the faint, ancient light from the edges of time. This was a time machine. Its mission was to answer the biggest questions: how old is the universe? How fast is it expanding? What's out there in the dark voids between the stars? The world watched on April 24, 1990, as Space Shuttle Discovery lifted off, carrying not just a telescope, but the astronomical hopes of a generation. Then, the first images came back. And they were horrible. Instead of the crisp, pinpoint stars astronomers were promised, the images were fuzzy and smeared. The most expensive telescope ever built was critically flawed. On June 27, 1990, a stunned NASA announced the unthinkable: their flagship observatory had a spherical aberration. In simple terms, the telescope was nearsighted. The primary mirror, the heart of the machine, had been ground to the wrong shape. The error was almost impossibly small. The outer edge of the mirror was too flat by just 2 microns, about 1/50th the width of a human hair. But in the precise world of optics, that tiny mistake was a catastrophic failure. It meant that light hitting the edge of the mirror focused on a different point than light hitting the center, resulting in a constant, maddening blur. The public and political fallout was immediate and brutal. After spending what was then well over $1.5 billion, NASA had launched what some politicians called a techno-turkey. Late-night talk show hosts skewered the agency. It was a national humiliation that shook faith in NASA, an organization still recovering from the Challenger disaster just 4 years earlier. The dream of a clear window to the universe had become a blurry, out-of-focus nightmare. For 3 long years, it seemed Hubble was destined to be remembered as one of the biggest blunders in the history of science. The race for a solution. So, how could this have possibly happened? An investigation, led by Jet Propulsion Laboratory Director Lou Allen, discovered the answer. The mistake wasn't made in space, but years earlier in a cleanroom at PerkinElmer, the company that made the mirror. The culprit was a device called a reflective null corrector, used to test the mirror's precise curve. A single, tiny spacing error within that testing device, off by just 1.3 millimeters, had guided the polishing machine to create a perfectly smooth, perfectly wrong shape. The diagnosis was devastating, but it also offered a glimmer of hope. Because the flaw was consistent, it was correctable, at least in theory. The challenge was, the telescope was already in orbit. You couldn't just bring it back to the shop. The solution had to be delivered to it. Engineers at NASA devised a plan that sounded like something straight out of science fiction. They would build a pair of glasses for Hubble. The concept was named COSTAR, which stood for Corrective Optics Space Telescope Axial Replacement. It wasn't a new camera, but a complex device the size of a telephone booth, containing a series of small, deployable mirrors. These tiny mirrors, some no bigger than a dime, were shaped with the exact opposite error of the main mirror. Once installed, they would intercept the blurry light, correct its path, and feed a perfectly focused image to 3 of Hubble's original instruments. Meanwhile, a brand new camera, the Wide Field and Planetary Camera 2, was built with its own internal corrective optics already installed. The plan was to swap the original camera for this new one and install COSTAR to fix the vision for the remaining instruments. Nothing like this had ever been done before. While Hubble was designed to be serviced in orbit, a repair this delicate was unprecedented. For 2 years, engineers worked relentlessly, even building a simulator of Hubble's flawed optics to test COSTAR on the ground. At the same time, an elite team of astronauts began one of the most intense training regimes in NASA history, spending hundreds of hours in underwater labs, practicing every single step of the repair. This mission could not fail. The reputation of NASA, and maybe the future of big science space projects, was on the line. The daring repair and redemption. On December 2, 1993, the Space Shuttle Endeavour launched on mission STS-61. On board was a crew of 7 veteran astronauts on a mission to perform the most complex space repair ever attempted. After a delicate chase, astronaut Claude Nicollier expertly grappled the school bus-sized telescope with the shuttle's robotic arm and gently guided it into the payload bay. The celestial surgery could now begin. Over 5 consecutive days, 4 astronauts conducted a record-breaking 5 spacewalks, totaling more than 35 hours. Working in bulky spacesuits against the blackness of space, astronauts Story Musgrave, Jeffrey Hoffman, Tom Akers, and Catherine Thornton performed a series of incredible repairs. They replaced the solar arrays and faulty gyroscopes. Then came the main event. During one spacewalk, Hoffman and Musgrave carefully slid out the original camera and installed the new, corrected WFPC-2. On another, Thornton and Akers removed a different instrument and slotted CoStar into its place. The glasses were in. With every bolt turned, the hopes of the entire astronomical community hung in the balance. After boosting Hubble into a slightly higher orbit, the crew released it. The world held its breath. Back on Earth, scientists waited nervously. On December 31, 1993, they pointed the repaired telescope at a distant spiral galaxy named M100, a target that had been a frustrating blur before. The first images came down. And they were perfect. Where there was once a fuzzy blob, there was now a brilliant, crisp galaxy, its spiral arms glittering with individual stars. The before and after pictures were astonishing. The blur was gone, replaced by a vision so sharp it brought tears to the eyes of the engineers who had worked for years to see it. Senator Barbara Mikulski, who had once called Hubble a techno-turkey, now triumphantly declared, "The trouble with Hubble is over." NASA wasn't just redeemed, it was triumphant. The billion-dollar mistake had been transformed into one of NASA's greatest comeback stories. With its vision corrected, Hubble kicked off a scientific revolution. Its observations were a crucial piece of the puzzle that helped scientists pin down the age of the universe at around 13.8 billion years. It delivered some of the strongest evidence yet for supermassive black holes, helping establish that most large galaxies have one at their center. Its data on distant supernovae revealed that the expansion of the universe is accelerating, a Nobel Prize-winning discovery that gave us the theory of dark energy. And it was one of the very first telescopes to give us a look at the atmospheres of planets outside our solar system, detecting elements in the air of alien worlds. Hubble's images, from the soaring pillars of creation to the cosmic kaleidoscope of the ultra-deep field, have become cultural icons, changing not just what we know, but how we see our place in the cosmos. It truly became the people's telescope, a testament to its profound connection with the public. The story of Hubble is so much more than a story of scientific discovery. It's a profound lesson in perseverance. It's a reminder that failure often isn't the end, but an unexpected step on the path to greatness. That initial, epic blunder didn't blind us. Instead, it just made the moment we could finally see clearly that much more spectacular. What Hubble discovery do you think is the most mind-blowing? Black holes, dark energy, or seeing the universe as it was billions of years ago? Let me know in the comments below. And if you want more stories about the science that changed everything, hit like and subscribe so you don't miss the next one.